Derivative at a point. Definition. For a real valued function f defined on an open interval a, b, with c lying between a and b, fx is said to be differentiable at x equals c if and only if the limit x going to c f of x minus f of c divided by x minus c exists finitely. This limit is referred to as the derivative of fx at x equals to c and is denoted by f prime of c or dfc, where d is the derivative operator, or d dx of fx, also read as the derivative of f of x with respect to x, calculated at x equals to c. Thus, we have f prime of c is equals to limit x tending to c, f of x is equals to f of c divided by x minus c, provided the limit exists. We will assume that a given function f of x is differentiable at every point in its domain. That is, the right-handed limit with limit x approaching c from the right-hand side, f of x minus f of c divided by x minus c must be equal to the left-handed limit where x approaches c from the left-hand side. We have f of x minus f of c divided by x minus c. So this implies that f prime of c is equals to limit h tending to 0, f of c plus h minus f of c divided by h, or f prime of c is also equals to limit h tending to 0, f of c minus h minus f of c divided by negative h. Consider a real valued function f defined as f of x is equals to x squared plus 1. We have to determine the value of f prime of 2, that is the derivative of the function at x equals to 2. So we're here given the function f of x is equals to x squared plus 1, and we're going to use the definition f prime of c is equals to limit h tending to 0, f of c plus h minus f of c whole divided by h, with c equals to 2. So that is, we get f prime of 2 is equals to limit h tending to 0, f of 2 plus h minus f of 2 divided by h. Let's set this as equation number 1. Now we determine the value of f of 2 by plugging x equals to 2 into the fx, so that gives us 5, and f of 2 plus h, so that should give us 2 plus h whole squared plus 1, and when we solve this we get 5 plus 4h plus h squared. Now we're going to replace this value in the equation number 1, so we have limit h tending to 0, 5 plus 4h plus h squared minus 5 divided by h. The 5 and 5 gets cancelled in the numerator, and that leaves us with 4h plus h squared. So we can factor out the h in the numerator, which cancels out with the denominator, leaving us with 4 plus h. Now we finally apply the limiting value, and that gives us 4. Problem number 2. Consider a real valued function f defined as f of x is equals to x squared minus 2. We need to determine the value of f prime of 10. So here we are given the function f of x is equals to x squared minus 2. So using the definition, we have f prime of 10 is equals to limit h tending to 0, f of 10 plus h minus f of 10 divided by h. Now f of 10 will be equals to 10 squared minus 2, so that is 98, and f of 10 plus h, so that should give us 10 plus h whole squared minus 2. And when we expand 10 plus a whole squared by using the formula for a plus b squared, and that should give us 98 plus 20h plus h squared, such that f prime of 10 will be limit h tending to 0. So we have f10 plus h replaced by 98 plus 20h plus h squared minus 98 divided by h. The 98 and 98 in the numerator gets cancelled, leaving behind 20h plus h squared in the numerator. We're going to factor out h from the numerator, so we have h times 20 plus h divided by h, so h and h from both the numerator and the denominator gets factored out, leaving us with 20 plus h. Now we use the limiting value, so we have limit of h tending to 0, 20 plus h, so that gives us 20. Problem number 3. Consider a real valued function f defined as f of x is equals to thrice x. So we need to determine the value of f prime of 2. So here we have the function f of x is equals to thrice x. So from the definition we have f prime of 2 is equals to limit h tending to 0 f of 2 plus h minus f of 2 whole divided by h. Now f of 2 can be determined by replacing x with 2 in f of x is equals to 3x, so that should give us 3 times 2 is equals to 6. So f of 2 will be equals to 6, and then f of 2 plus h will be 3 times of 2 plus h, so that should give us 6 plus 3h, such that we are going to replace these values into f prime of 2. So we get 6 plus 3h minus 6 divided by h. The 6 and 6 gets cancelled out, leaving us with 3h in the numerator and h in the denominator, which also the h also gets factored out, and that leaves us with limit h going to 0, 3. So the value is 3. Problem number 4. So here we need to determine the derivative of the function cosine of x at x equals to 0. So we are given the function f of x is equals to cosine of x. We need to determine the derivative of the function at x equals to 0, so that means we need to find f prime of 0. Now using the definition, we have f prime of 0 is equals to limit h tending to 0 f of 0 plus h minus f of 0 divided by h. Now f of 0 will be equals to cosine of 0, that is 1, and f of 0 plus h, so that will be equals to cosine of 0 plus h, which is cosine of h. Now we're going to replace this value into a definition, so that gives us f prime of 0 is equals to limit h tending to 0, so we have cosine of h minus 1 divided by h. So we are going to use the half angle formula. So we know that cosine of h is equals to 1 minus 2 sine squared h over 2. Now we can rewrite this equation as cosine of h minus 1 is equals to negative 2 sine squared h over 2. What we're going to do is we're going to replace the numerator of cosine of h minus 1 with negative 2 sine squared h over 2. And which is divided by h. Now we are going to do a little more adjustment. We are going to again divide both numerator and denominator by 2. So that gives us negative sine squared h over 2 divided by h over 2. Then we are going to multiply the numerator and denominator again by the factor h over 2. So we have a squared h over 2 in the denominator, and we have an h over 2 in the numerator. Now we're going to write the limit in a more seasoned way. We have limit h tending to 0 negative h over 2 multiplied to limit h tending to 0 sine square h over 2 divided by h over 2 whole squared. So the first limit is going to be 0, and the second limit, this is the formula for limits, sine of h over 2 divided by h over 2, so that should be 1, and we finally get the product 0 and 1, so we have 0, hence the value of the derivative at x equals to 0 is 0. Problem number 5. What will be the derivative of f of x is equals to sine of x at x equals to 0? So here we are given the function f of x is equals to sine of x. We need to find f prime of 0, which will be equals to limit h tending to 0, f of 0 plus h minus f of 0 divided by h. So now we know that f of 0 will be equals to sine of 0, which is 0, and f of 0 plus h will be sine 0 plus h, so that should give us sine of h, such that f prime of 0 will be limit h tending to 0, sine of h minus 0 divided by h. So we have sine of h over h with the limiting value h going to 0, and the value is 1. Problem number 6. What will be the derivative of f of x is equals to 2 cosine of x at x equals to pi over 2. So here we have the function f of x is equals to 2 cosine of x. So we need to determine the derivative of the function at x equals to pi over 2. So we know from definition that f prime of pi over 2 will be equals to limit h tending to 0. So from definition we know that f prime of pi over 2 will be equals to limit h tending to 0 f of pi over 2 plus h minus f of pi over 2 divided by h. So we need to quickly determine the value of f of pi over 2, so that will be equals to 2 cosine of pi over 2. We know that cosine of pi over 2 is 0, so we get 0. And f of pi over 2 plus h will be equals to 2 times cosine of pi over 2 plus h. We know that cosine of pi over 2 plus h is negative sine h, so we have negative 2 sine h. Let's replace those values of the numerator with the found value. So we have limit h tending to 0, negative 2 sine h minus 0 divided by h. And now we can pull out the negative 2, so we have negative 2 times limit h tending to 0 sine h over h, which by definition is 1. So we have negative 2. So this is the value of the derivative at x equals to pi over 2. Problem number 7. What will be the derivative of f of x is equals to sine 2x at x equals to pi over 2? So here we are given the function f of x is equals to sine 2x. We need to determine the value of the derivative of the function at x equals to pi over 2. So we are going to use the definition. So we have f prime of pi over 2, so that will be equals to limit h tending to 0 f of pi over 2 plus h minus f of pi over 2 whole divided by h. Now we're going to determine the value of f of pi over 2, so that is equals to sine 2 times of pi over 2. So that gives us sine pi, which is equals to 0. And f of pi over 2 plus h, so that is sine of 2 times of pi over 2 plus h. So that should give us sine of pi plus h. And we know the sine of pi plus 2h is equals to negative sine 2h. So we're going to replace the denominator with the respective values. So we have negative sine 2h over h. Then we're going to multiply both numerator and the denominator with 2. And we can pull out the constant negative 2 out of the limit. So we have negative 2 times limit h tending to 0 sine 2h over 2h. And we know that this limiting value is 1. So that finally gives us negative 2. Hence f prime of pi over 2 is equals to negative 2. Problem number 8. Consider a real valued function f defined as f of x is equals to x squared plus 4x plus 3. Determine f prime of 3. So here we are given the function f of x is equals to x squared plus 4x plus 3. We need to find f prime of 3. That means the derivative of the function calculated at x equals to 3. Now we're going to use the definition f prime of 3 is equals to limit h tending to 0 f of 3 plus h minus f of 3 divided by h. Now f of 3 will be equals to 3 squared plus 4 times 3 plus 3, so that gives us 24, and f of 3 plus h will be 3 plus h whole squared plus 4 times 3 plus h plus 3, and when we expand it we get the value 9 plus 6h plus h squared plus 12 plus 4h plus 3. Combining the like terms gives us 24 plus 10h plus h squared. Now we're going to use this value and put it into the numerator, so that gives us f prime of 3 is equals to limit h tending to 0. So we have 24 plus 10h plus h squared minus 24 whole divided by h. So the 24 and 24 gets cancelled in the numerator, and we can also factor out h in the numerator, so that gives us h times 10 plus h whole divided by h. We can cancel out h from the numerator and the denominator, leaving us with 10 plus h with limiting value of h going to 0, and when we finally put the value of h, limiting value of h, we get 10. So therefore f prime of 3 is equals to 10.